First off, welcome to Cloud AI Huddle. My name is Puneet, and I'm on Cloud AI engineering team, focused on AI developer adoption, and so it's all again about you. I would like to invite you to check out two of our links: the Bitly AI Huddle, which the TLDR over there is AI Huddle is the open collaborative developer first forum, which is driven by Google AI expertise. And this is a forum where you get connected with Googlers and will help you solve your AI problems, right? And the second thing is, which we launched or announced last week, was Cloud AI Office Hours. It's still in a pilot, and it's a program where you can connect over VC, virtual conference, with Googlers and talk through some of your problems you're facing, right? And it's a great way to get unblocked in a really quick fashion. And then also a quick shout out to our entire Cloud AI community. We have 950 members as of I think yesterday. And again, it's a shout out to you all. So thank you so much for the enthusiasm, and just sort of continue the momentum and help us help you unblock in your AI journey. With that, I'll hand it over to Shantanu. Shantanu, take it over.
Yep. Hi, I'm Shantanu. I'm going to do a quick intro, although Brian is amazing. I don't know if I can cover all of this quickly, but Brian Kobashikawa is a senior interaction designer on the Cloud AI team at Google, and the workflows that you're going to see today were designed by Brian. So basically, from the inception, like from scratch, going from zero to what you're going to see today, it's been an amazing journey, and we launched AutoML Vision recently, and so you'll get to see to a certain extent how we actually arrived at some of the design decisions. Brian previously worked in the material design team at Google, and before that, he has worked at various UX organizations, including multi-year stints as the lead visual designer for Yahoo Mail and Yahoo Messenger. Over to you, Brian.
All right. Well, thanks very much. Can everybody hear me okay? All right, so yeah, I think the agenda for tonight is going to be fairly straightforward. We'll sort of start off with just an introduction to AutoML Vision overall. Then we'll sort of jump into a demo, hopefully a live demo. And then after that, kind of the part that sort of strikes me as being kind of the most salient part from my perspective is the deeper dive into the user experience or the UX. And so as a result, this talk will probably be a little bit different than probably previous AI meetups in that it's sort of focusing very much on how products are, product experiences are designed at Google, and especially sort of in this nascent emerging AI space, and how we're sort of trying to sort of tackle the myriad UX challenges that are sort of present throughout these experiences. So first off, let's go with start with an introduction to AutoML Vision. And to kind of start with that, we have sort of the mission for the computer vision group as a whole. And that's sort of to help developers build next generation computer vision powered autonomy solutions. And so this blue bar over here sort of represents kind of the area of work that we're sort of focused on, that being our pre-trained machine learning APIs and AutoML. AutoML being, there are 3 products that launched at Google Next 2018, just a few months ago. That'd be AutoML Vision, AutoML Natural Language, and AutoML Translation. And the foundation for those ML APIs and AutoML are sort of the technologies and research and the various decades of research of work that have happened on the Google Machine Perception team. Sort of the investments into TensorFlow and cloud-hosted TPUs sort of drive the sort of development of these products, which can then in turn drive a variety of different use cases. And those use cases kind of span a large variety or a large sort of gamut, sort of ranging from energy, like say for like in the vision case, like being able to detect spots of corrosion on a wind turbine, for example, all the way to something like retail, where maybe you have a product catalog and you want to recognize objects in photos that match that catalog. So as it turns out, the pre-trained machine learning API, the Vision API, is sort of that can actually address a lot of those use cases. So it's sort of the, it's a pre-trained model. It has a variety of different features, and you can learn more about it at cloud.google.com/vision. But the sort of the variety of features that it has are sort of presented here. These bottom four on the bottom right, the handwriting, OCR, product search, object localizer, and web detection, were announced at Next 2018 back in July. But there's sort of like a variety of different use cases that these features sort of handle, ranging from optical character recognition, being sort of being able to like scan and transfer large amounts of paper documents at scale, to labeling, to logo detection, image properties like sort of common colors or dominant colors. So the pre-trained Vision API would sort of handle a lot of these particular cases. And if you go to the ML API section on the cloud website, you'll see that there's a video intelligence API, there's a natural language API, translation API. Translation API has been around for a while, actually. But the question sort of emerges is what happens if the data that you're looking for, or the objective that you're sort of going for, sort of belongs to a different domain, and you need to support these very specific concepts that may not necessarily be covered by the Vision API. And so probably the answer that a data scientist might come up with is that they would create their own computer vision model. And so over here we sort of have sort of laid out, sort of very roughly kind of the different stages of constructing that model. But along that way, there's sort of a variety of questions that data scientists would be asking, and these are sort of questions that have come up sort of in the UX research and other sort of initiatives that we've been doing in the past, such as when you're sort of doing your data pre-processing, one of the questions you might ask is like, well, what pre-processing techniques should I use? When I move over to the next couple of stages, the model design and being able to tune those parameters, the questions that those users would ask would be, well, what technique should I be using? If I'm doing deep learning, which architecture should I be selecting, and what set of hyperparameters should I be tuning? And then once you move over to the evaluate step, then it starts to get into sort of this whole goal around being able to sort of analyze that data, like understanding what metrics are sort of most important or most relevant to my objective. How do I know that my model is actually performing well? What are some ways for me to actually improve my data set so that if I were to retrain, it would actually produce better results? And then for deployment, then there's a question around what infrastructure should I be using to be able to serve this model at scale, or like how do I meet my overall latency goals? And then there's like this process of updating, and then that sort of cycles back to the previous step. And so you might end up asking these questions multiple times as you're starting to go through and kind of improve your data set. And as you're sort of like answering these questions along the way, that could start to get pretty expensive as you're starting to choose all these different pathways and see what combination sort of works best and produces the best outcome. And then any time that you were to say change your objective or shift it around, then you kind of have to start over from the beginning in many cases. So what we started to look at with AutoML is being able to take all those complex steps of building an ML model and being able to automate it somehow. And the way that we'll show it is we'll sort of see how it sort of manifests in a user interface. But what's the sort of goal of AutoML at that point is that it sort of allows you to focus on the actually collecting the right data and being able to define the right business objectives and still have a model that's of high enough quality that you can deploy to production. And so the workflow that you then manifests kind of gets distilled down to, well, you put together your data set with some training images and labels. You pass it into AutoML, which will sort of do the whole process of training your model, deploying your model, and serving your model on Google Cloud. And then what you end up with is a simple REST interface for making those types of predictions. So what types of capabilities does AutoML currently have, or AutoML Vision currently have? Well, we have single label classification. So this is sort of like the case where you might have an image that should be only one of several classes. So the example that we bring up here is one where you're sort of trying to distinguish different cloud types from each other based on like the overall sort of physical properties, visual properties of these clouds. And this could be one of those inputs to help build a pretty good indication of what the weather is going to be like. Another case would be something like the other sort of side of it would be multi-label classification, where an image can have several classes. So one example might be maybe you want to create like this giant latte art database, and you have all these different sort of indicators of what types of properties this latte art should have. And maybe at some point you want to, like, when people upload new images of their latte art, they can sort of have it automatically categorized and easily browsable and all that. But this would be a case where like you would not necessarily want Feather to win out over latte or etching to win out over mocha, but rather it's like they would all sort of share those common properties. So what kind of happens sort of under the hood is that AutoML can actually use AI to build AI. So what we sort of mean by that is that we actually introduce once you submit your data set to AutoML, an AI agent will sort of come in and sort of be able to build this model that uses deep learning techniques that has sort of the optimal architecture and set of hyperparameters to solve your particular business need. And where that sort of manifests, back in April, there was this article that came out that showed this Japanese researcher over in that was able to take photos of ramen. And there's this shop called Ramen Jiro. They have 40-some locations. And what this researcher was able to do was like take, I believe, 1,000 photos from each of those shops, and then be able to pass that into AutoML, train it for about 24 hours. And when all was said and done, it was able to predict which specific shop that ramen came from with something like a 95% accuracy, that being like 94-point-something% recall, 94-point-something% precision. So that was like an interesting case because like I myself am a giant ramen fan, so I was kind of there's very rare that articles about AI make you salivate, but that happened to be one of a couple. But yeah. Anyway, so where UX starts to get involved is this whole process of creating user stories and scenarios. And so we'll start with kind of a simple one. So we'll start with this user. We'll call her Jane. She's a developer at a wildlife conservancy. Maybe she's familiar with the Cloud Vision API, but she's probably familiar with like implementing APIs in general. She happens to have a lot of images on hand, but she has very direct, little direct ML experience. She's more of an ML enthusiast. And so, unfortunately, this photo is a little washed out, but it's a little silhouette of a flightless bird right there. So what she wants to do is create a bird classifier so she can improve the experience of her ornithology app. So maybe what ends up happening is she ends up using the Vision API, sort of the pre-trained Vision API, to handle a lot of her labeling techniques or labeling tasks. But in the case of like being able to distinguish emus from cassowaries, from rheas to ostriches, she wants to create an even more custom model to sort of address that. And so, what will be some ways that she might do this? Well, there's a couple of different approaches. One is that she could sort of use this sort of Wizard of Oz approach, where when users submit images, she'll sort of surreptitiously take these images and send them to a human labeling pool somewhere that will sort of go in and label these images for her and send it back, and then this gets sort of indexed by the database. But you can sort of see where this starts to get not all that scalable in the long run, where the cost will sort of increase as the number of users increases. The number of, if she decides to expand her reach beyond just these 4 classes, then that starts to complicate how she interacts with this labeling service. And if she wants results in the matter of seconds rather than minutes or days, then this is probably not the right solution for her. Another possibility is that she could use the Vision API, but as mentioned earlier, these categories may not necessarily be all that specific enough to meet her use case. The third option, which we kind of brought up a few slides back, is that she could write a model herself, but as mentioned by her persona description, she doesn't have the AML expertise to build that model. So what we sort of offer as kind of the ultimate solution is to use AutoML Vision, where Google can basically train a model off of her own images and labels. And so this is where we get into a demo, and hopefully this will work. So this is so kind of as setup, this is I had created a folder called birds on the left, and within there I created 4 folders with the different labels that I want. And then within each of those folders, I sort of just threw in all the images that I want labeled ostrich or emu or rhea. So if I can go here, I'll go here, and this is the AutoML Vision sort of interface. This is me creating a new data set. So I can go here and say, okay, I'll call this birds. And from here, I can import my images, and there's 3 different options. So one option is the one that sort of is suited for my purpose, which is to basically just upload these images from my computer, where I just select these files, and I'll say, okay, I'll take this birds.zip, I'll hit open, and it'll just sort of pop in like so. The other main option that we have is that you can select a CSV file on Google Cloud Storage, and this would be particularly useful if you have like an inordinately large amount of images, in which case you might want to use Google Cloud Storage's tools in order to get massive numbers of images into your data set. The other possibility is that maybe you want to control the training, validation, testing split, in which case you can sort of specify what bucket it should go into within the CSV file itself. And so there's like a little sort of code over here that kind of describes how that sort of syntax kind of works, where you have the path to the location of your image on Google Cloud Storage, and then you follow it with a comma and then put the label or labels after it. And then if you wanted to sort of specify whether it's in training, validation, or testing, then you would prepend that line with training, validation, or test. And so this is sort of more for like kind of users that are maybe a little bit more advanced, that would sort of know how data splitting works and have best practices around it. So we kind of don't necessarily surface it at this point, given that we handle the split sort of automatically if they just sort of leave it empty for now. And then the third option is that they can import their images later. So they would essentially start with an empty data set, and then they can, through the interface itself, they can throw in their images and sort of label them, either sort of label them manually within the UI, or use the human labeling service that's also built into the UI. And then this last option over here is just basically specifying what the classification type is. So whether it's sort of single label classification by default, but you can optionally choose to make this multi-label classification. So at this point, I would hit create dataset, and then it would sort of churn for some amount of time. It sort of depends on the size of your data set, but I think for this one, it took probably about 20 or 30 minutes or so. But we're not going to wait 20 or 30 minutes here, because I don't really have a whole lot to say during that time. So what I'll end up doing is I'll just sort of skip over to the actual created data set here. So hopefully this works. So my internet connection's been kind of wonky all day, so we'll see. So here, this is after I uploaded my zip file through that create form, and 20 or 30 minutes later, it sort of pops in this sort of browser over here. And so I can sort of see all the images that were imported and the labels that are associated with them over here. And furthermore, what I can do is I can sort of narrow it down to a specific label here by clicking on this item over here. So I sort of narrow it down to just the cassowaries, or I go over here and I see my ostriches. And what I can also do is I can go in to individual images over here and say, this particular image right here, let's say hypothetically that this wasn't an emu, it was actually an ostrich. I can go in here and say this is an ostrich, hit OK, and then it will sort of update that data set. So you can sort of go in kind of like one by one and update these images. Or you can select it over here, and you can do like sort of a click. You can do a click select, or do a multi-select over here to do multiple images, and hit the label button and sort of do a mass relabeling of these images to say, for example, emu. So it's all sort of like kind of built in here, and like it's sort of also built to handle sort of a large list of labels as well. So you have access to like filtering over here, so I can like filter it down to cassowaries this way. or I can sort of just select on here. There's like a filter over here. So it's sort of like kind of geared towards like being on the order of like, a couple hundred labels that you can potentially have in this case. Once I move over to the train tab, this would be sort of the next step. And at this point, ordinarily I'd be sort of prompted with the sort of a prominent call to action to allow me to train a new model. So I click on this guy, and I can say, okay, this is my model, and I'll give it a 1 compute hour training budget, which is free for the first 10 models for each month. I also have the option of specifying a larger number of compute hours, which we'll get to later. And so once you sort of submit your train request, it'll sort of churn for another amount of time. And I think in this case, it took about 15 to 20 minutes or so, and it produced a model that looks something like this. I also actually trained 2 models this morning. Actually, this one performed slightly better than this one. So the results that I get is that I get sort of an average precision of 0.947. And if I were sort of one that was not sort of accustomed to these particular values, I might sort of look at this tooltip and say, okay, what does this 0.9 whatever mean? And so then if over here it says that 1.0 is the maximum score, so that sort of means that it's looking pretty good right now. My precision and recall are good but not great, so maybe what I'll do is I'll take a look at the full evaluation and see what's going on. And so this sort of clicking that See Full Evaluation takes me to the 3rd tab in this list, which is the Evaluate tab. And from here, I can sort of take a look at the All Labels panel and get sort of like sort of a deeper dive into these precision recall graphs. So I can sort of move my score threshold around and sort of see how that sort of affects the precision recall graph as well as the precision at 1 and recall at 1 graph. So for a more advanced ML user, they could sort of see here like what threshold would sort of make the best sort of trade-off between precision and recall. Or if they want to sort of like anchor it more towards recall, they can move it over here, which would sort of produce more false negatives as false positives as a result. And then if I were to move it over here, then it would sort of anchor it more towards precision. And then down below here, there's a confusion matrix. So this sort of gives you kind of a 4x4 of the true labels versus the predicted labels. And when I sort of look at this over here, I can see that for cassowary and emu, it actually performed pretty well. For ostrich, it performed okay. 85% is good, but not particularly great. But it really suffered on the Rhea class, and so it looks like it confused Rhea with ostrich quite a bit. And having looked at birds for the last couple days, it seems that Rheas indeed, although they're a much smaller bird, and they come from a different continent. I believe they're from South America as opposed to Africa. They look astonishingly like ostriches, and that was something I was not entirely aware of. So if I go over here, I can sort of see kind of like a specific precision recall curve for this particular label, and I can see the list of true positives that came back for this particular label. So these are all different Rheas. And I can see some of the false negatives. So this would be like photos that were properly identified as Rheas, but were not above that 0.50 score threshold that I had specified up here. And then down here are some false positives that I got. So these are ones where it was labeled Rhea, or it should have been. These are ostrich photos, but we ended up predicting Rhea for whatever reason. And like in this case, like this is clearly an ostrich, but for whatever reason, it's the Rhea label sort of edged it out for whatever reason. And that whatever reason is where sort of building that kind of that sort of intuition around how this model is sort of working starts to allow the user to kind of formulate some interesting follow-up actions on like, what should they do next to sort of improve their model. So one option that they could potentially do is is one that we sort of say up here is that basically if you were to add more images to your data set, this would probably allow you to improve your model. And if I look at my label stats, I actually only uploaded just a couple hundred images for each of these labels. And as it turns out, for cassowary and emu, I mean, maybe this might suffice because like it seems to perform pretty well. But for ostrich, I had 400 images, and for Rhea, I only had 200 images. Maybe I should add more Rhea images in order to see if I can get my metrics up. Another possibility that I might want to do is just take a look at these images and see maybe I might have mislabeled some of these images. And so like in this case, Like this one was the ground truth is an ostrich, but I think this is actually a rhea, and I think maybe I just went in and mislabeled these images. So another thing that I could potentially do is backtrack to the images tab over here, and go to my rhea section, and basically kind of scan through and see if all these are rheas, and then likewise go to my ostrich section and see if any of these are mistakenly identified as rheas when they should really be ostriches. So this could be something that maybe I might do, or it's something that I could sort of offload to a coworker of mine. Maybe it's something that I can sort of export this data set to a CSV file and sort of look at this offline. There's a couple of different ways to go about that. And then the last option that you could potentially do is basically throw more compute hours at this model. So we only trained it with 1 compute hour, which actually translates to about 15 to 30 minutes or so. But if I were to say train a new model and give it a much more substantial training budget, it's quite possible that throwing more compute hours will give me a better model with the same data. But this is something that you can sort of, you can max out on, but you can also sort of customize. You can say, maybe I just wanted to try out 2 at first, and then see how things perform, and then I can go back and sort of resume training with an additional set of compute hours. So there's a couple of different options kind of at my disposal as far as like going in and sort of intervening and seeing if I can squeeze better performance out of this model. And then the last step that the user can do is go to this predict section, and they can this is sort of like the moment of truth where they can sort of click this button and upload some holdout images. So I have this image over here. This appears to be an emu. So we'll see if this thing will actually work. And yeah, it looks like it predicted an emu with 0.996% score. Ostrich was slightly represented, rhea slightly represented, but it's kind of almost so infinitesimal that it might not even matter all that much. And if I had set a score threshold of 0.5, then this would be sort of graded as an emu regardless. And then down below we have a couple of sort of code samples that will allow you to implement your custom model. So we provide some snippets for the REST API, and you can toggle over here to see sort of like a little mini Python script, so that you can sort of, like if you're sort of a person that happens to have a lot of training images on hand, but maybe not necessarily a lot of programming experience, you can sort of take this guy and kind of copy it and paste it and send it to your web developer and say, hey, can you help out here and see if we can get this thing to work? But in the meantime, the model itself has been deployed to and is sort of readily available for predictions. So that's basically kind of the long and short of the workflow. And so let me just go back to the presentation. And so like from here we can sort of conjure up some ideas on like how all this sort of fits together, like different pieces. So like unfortunately there's sort of like a boundary that sort of encircles these 4 boxes in the center, but that sort of represents the Google Cloud Platform system. And so one workflow that you can sort of imagine is that maybe a user uploads new images from their computer. It gets sent into Google Cloud Platform. It gets stored on cloud storage, which will then trigger a new image notification via the PubSub Google Cloud product, which then gets sent to App Engine, which is what the search index is based on. And what can happen there is that, well, App Engine could sort of call the AutoML Vision API and say, okay, I got these 3 new images. What do these images look like? And the AutoML Vision API can return back predictions on, well, this is an ostrich, this is an emu, this is a rhea, and store that in a search index on App Engine, so that in step 5, the user can search for, say, ostrich or rhea, and be able to get those results sort of automatically tagged on their behalf. Now let's take a step back and take a deeper dive into the user experience. So user experience, or UX, is kind of, in the most general terms, at least at Google, loosely split into these 3 different branches. So there's UX research, UX design, and UX prototyping. And you sort of see that one feeds into the other, and there's actually some hidden arrows where it sort of cycles back in on itself. But so as sort of like a primer, on what these three different disciplines are. So UX research is all about sort of like better understanding the problem space, and that could be sort of through sort of interviews with stakeholders, with customers, doing academic research, being able to sort of gather insights from sort of a whole spectrum of sources, being able to sort of provide meaningful analysis and also sort of interpret the results so that it can be translated into sort of actionable steps, not just for UX design and prototyping, but also for the product management team, for engineering, et cetera. But as far as the scope of this discussion, the primary artifacts from UX research feed into the UX design, which is sort of the area that I'm most kind of rooted in, and that's sort of all around like kind of constructing the flows, the sort of the overall user journey, the way that the product is sort of constructed from like a visual and information hierarchy standpoint. It could also encompass visual design and motion design, so like things like transitions or what components are being used and how they sort of look like, the aesthetics are all sort of part of that kind of realm. And then that feeds into UX prototyping, also kind of known as UX engineering at Google, and that sort of is the ability to sort of take all these design and research artifacts and sort of encapsulating it into something that we can sort of something that's tangible that we can sort of show to stakeholders, to other team members, be it as a spec or as a demonstration, or most importantly in our case to our UX research participants. So this sort of gives us like an early sort of look at like how the design is going without necessarily getting too deep into the implementation side of things. And the way that prototyping sort of manifests, within the UX field, is that it sort of takes a variety of different levels of fidelity. Like it can sort of range from very low fidelity, like just a series of pieces of paper that have like a bunch of diagrams on it that you sort of just like show kind of in sequence, kind of mix it around. It could be something like a Google Slides deck or a PowerPoint deck where it's like a series of mock-ups that you sort of take a participant through or a stakeholder through. But then it can get into the very high fidelity where it's like it's actually a semi-interactive or fully interactive product that a participant can sort of directly interact with and sort of see how does this sort of like meet their expectations. And so one way that this sort of manifests is here on AutoML, where this is sort of like the live demo that I showed right here. This other tab right here is the UX prototype that we've been building over the last however long. And this is basically something that is using not real data, but it's using as many sort of UX patterns and components put together to see like how it sort of maps to users' expectations and allows us to sort of get a kind of a head start on how the how our design thinking is going without leaping directly into bugging a bunch of engineers to like make a bunch of back end and front end modifications that may end up not testing well. And so like in this case, like you can sort of see like that there's like this is all fairly functional. Like you can sort of kind of go in and like select a bunch of images. You can assign some labels and do all sorts of like activities that you would normally do with a live product, but this is sort of all done kind of all through smoke and mirrors essentially. And it's basically kind of used more or less as like an inherently disposable tool that we can use to do some rapid iterations on. So like one example, which unfortunately will not show up particularly well on this screen, was with a confusion matrix where we originally had started off with a matrix that looked kind of like this, where the positive values, the matches were green, the negative ones were red. But a concern came up that people with red-green color blindness may not necessarily see that sort of diagonal strip of green in the center there. It actually kind of looks all like shades of yellow or brown. So what we ended up doing was like use this prototype as a means of being able to like try out a couple different color palettes. So like being able to see, okay, let's see what it looks like with a blue-gray themed. We ultimately settled on the blue-orange theme over here because it sort of gives like a fair amount of prominence between the two. But the ability that we can sort of like kind of just sort of toggle between these different variants without necessarily impacting the rest of the flow, or like having to crank out a bunch of additional mockups, was one of the key pieces that we got out of this one. Another kind of quick example is like looking at one of these images over here. You can sort of see the predictions on the right. And but one thing that we're thinking about, well, what if we were to just sort of tweak the layout so that we want this column to appear on the left-hand side? So as opposed to like making a request through to our front-end engineers to like, try this out, see how it feels, we could just sort of like try it out on the side, see what are the pros and cons of this particular layout. Do things become more readable, less readable? How does it sort of align with how they've interacted with previous products in Google Cloud, et cetera? So if I jump back to the presentation here, so as we started to like kind of do a series of these iterations, like we had multiple rounds of testing on the research side, which led to a bunch of iterations on the design side, which led to a bunch of iterations on the prototyping side. We had started to a series of UX goals started to emerge, and I have a couple of examples of like where in the workflow these goals kind of manifest. So the first one was all around being able to sort of ground the user's mental model. And what that sort of means is that we ended up kind of taking the sort of traditional ML workflow, which is a semi-linear process, but has this tendency to sort of circle back in on itself, where like once you get to a certain point, like after say evaluating your model, you may circle back and label some more images and then kind of go back through this process again. But eventually the goal is to sort of end up at the very last step over here, and start to like see what are the different sort of subtasks or like sort of user stories that sort of align with these different sort of themes that are part of each of these steps. So it might be like something that's fairly straightforward, like well, as a user, I want to name the data set so that I can recall it later, or as a user, I want to specify whether this is single label classification or multi-label classification on the import side. To on the other side, like as a user, I want to be able to access some code samples so that I can be able to implement my model and deploy it. And where that starts to kind of where we started to see some sort of consolidation was seeing if we can sort of map these different steps of the workflow to specific states within the application itself. And so where that starts to kind of come to play is, unfortunately, it's a little washed out, but the idea that there's a create form over here on the left, which sort of leads to this tab set over here that encompasses these 4 steps. And you can sort of toggle between images, train, evaluate, and test and use or predict, and sort of be able to, because they're tabs, you can sort of like navigate backwards and forwards. So like here's sort of like maybe a little bit easier to see, or here's the create form, and then over here you see the images on the top left, train, evaluate, and predict. It's sort of representing those 4 stages of the ML sort of flow that you can sort of go back in any particular order and sort of jump forward in any particular order. There's no sort of like requirement to do all of the steps, but there's still sort of like this forward momentum that sort of propels you towards this last step over here. Another piece that kind of came to the forefront was being able to educate users on new concepts. And by new, I sort of mean new to users that have little ML expertise. And so this would be something that might be around like progressive disclosure. So like the tooltip that I showed earlier, where it's like, well, average precision is kind of this weird, foggy concept to people that might not have ML expertise. And then precision and recall, they sound intuitive, but maybe we need to like provide some additional text to help sort of bring more clarity to this particular term. And so this is something that we've been doing a couple of subsequent iterations on to see if we can make this language increasingly clear to people that might have that might struggle with understanding these sort of broad concepts. And so it's something that we're it's still kind of a work in progress. Additionally, things like distinguishing between a false negative and a false positive would be areas that we would sort of investigate more fully in the detail view, where we showed like the list of predictions. So here we have a list of labels and the scores they received, but then we also sort of indicate which one was the ground truth by this little star over here, and sort of indicate like, well, this label because it was above 0.5, which was the score threshold that you had set, and it was not the ground truth, we're sort of deeming that as a false positive. And then meanwhile, this one that's below 0.5, that starred, is a false negative. So trying to like kind of reintroduce these concepts over and over and again through the product itself is another thing that we're trying to do to kind of produce like a more infuse more user education directly into the UI. So that's sort of like kind of AutoML Vision more or less in a nutshell. And we have two other products, as mentioned earlier, that launched at Next as well. So we have AutoML Natural Language, which is essentially it's kind of like the same principle as AutoML Vision, but it's dealing with basically with free-form unstructured text, sort of like documents. So the the sort of use cases around that are there's a variety of them that are associated with that. And then down below we have AutoML Translation, which is more about being able to take the existing translation API and being able to sort of augment it with your specific use cases. So like if there are certain needs or like certain words or idioms, pieces of vernacular that the current translation API is struggling with, if you have like a whole series of sample sentence pairs, you can pass that into AutoML Translation and build a custom model for that. So you can find out more about AutoML by going to this link, which is actually repeated over here. And this is sort of also an opportunity to promote our office hours. So if you have a lot of like questions around the underlying technology for AutoML, or like want to find out more about like how AutoML sort of works under the hood, it's possible that through office hours we can pair you up with somebody that might have more of that knowledge base on there. All right, well, thanks very much.